Okay, guys, so welcome to this Apex presentation of understanding fascia. And as always, it is what you need to know for gym floor application. Key questions. So I always outline what we'll be discussing today, what the outcome will be in terms of the questions that I need to make sure that I am answering. And the first one, very, very simply, is what is fascia and why does it matter? Then we're going to have an introduction to the myofascial lines themselves. How does it impact our own training? So with each line, I'll go into how that affects things. How does it affect our program design? Common exercise issues, and then just some cool tips and tricks. Just to verify with the tips and tricks things is that fascia release thing, where you rub into your jaw or you do a little bit of a manipulation. As a personal trainer, if you do not have any form of soft tissue qualification or insurance, is completely illegal. So just to verify things, just if you do see things online, because people like it these days, is clickbait where it says, rub this spot and then suddenly you get loads of range of motion. That's something that we won't be covering, because even though it's cool, if you're just a PT, in terms of your qualifications, you do that on your client and they injure themselves, you're in a lot of trouble. So just bear that one in mind. If you do see that online, it's misinformation. So what is fascia? This is the bit, I could say the boring bit, in terms of it does help to understand things. There's a lot of fancy words which we can throw around. It's essentially something called the extra cellular matrix, not matrix that I've put there. It's containing collagen, elastin, and a gluey interfibrillar protein called ground substance. In terms of how does that help? I personally think that the collagen and elastin can interchange. This is just an opinion, is that sometimes people have different percentages of different ones, such as elastin and collagen, which will make them more efficient at certain things, more elastic, more resistant to things. They have a little bit more rigidity in tendons, tissues, fascia, and so forth. Whereas other people might have a more elasticity. And so again, the difference between the two of them, which essentially makes certain people better at one thing and certain other people better at others. So things like being mobile, or very, very mobile, you might have a slightly increased in proportion of elastin. Where if you're more rigid, it's an increase in collagen. That might be someone who's incredibly powerful with a small body weight. But a direct quote from the book, Anatomy Trains, is just, it's a living matrix and a continuous dynamic molecular web work. And what that just basically means is fascia encases everything. It encases muscles, tendons, tissues, organs, like we'll see in this slide here. It connects everything to everything. And the reason why it's there is a way of kinetic energy transfer. And this is our ability to absorb force and then apply it. So my biggest gripe with the traditional model of training, and something that has been highly popularized, is that we look at things from a purely reductionist point of view, as in this is a bicep, it curls, it flexes the elbow, and so forth. Then in the fitness industry, especially in the bodybuilding realm, there's been an obsession with yes, joint mechanics. This is what a joint does, and so forth. But essentially, we wouldn't be able to move, walk, run, jump if there wasn't a way of that bicep connecting itself to the shoulder, and then that shoulder connecting itself to the torso, that torso connecting itself to the spine, and so forth. And when I say energy transfer, is that when a muscle contracts and creates kinetic energy and movement within that bones, is that the movement itself is going to apply force or get the joint to move in a direction, which then needs to be applied to the opposing joint. And this is done through that kinetic energy, which is transferred through the fascia. So think of it as like an electric conduction system for kinetic energy. It's incredibly important during walking. And as I explained in APX level 1, is that if we didn't have fascia, or if we purely relied on muscles to move, this would be incredibly inefficient from an energy point of view. So let's simplify this. When we're hunter-gatherer, when we're evolving for millions and millions of years, if we needed to expend glycogen, to expend energy just to walk, then we'd have an issue where in times of famine, when we couldn't find food, especially when walking long distances. So therefore, think of fascia as putting on some form of cruise control system where we learn how to control falling So essentially walking is falling to the ground, where we then learn how to utilize the force to then take a next step. So that's a way of thinking about gait, and it's a way of thinking about energy transfer. It's a way of thinking about fascia. If we purely had to use muscles to create movement and therefore glycogen from muscles, we wouldn't have survived. We wouldn't have basically been able to walk long distances while seeking food. So like everything is that if you look into evolution and the way the body had to develop, it makes a lot of sense into why that fascia is there. So this is an analogy I've used for years, and it's, for me, it works. It works really well for anybody in a layman's terms. If you come into this completely fresh, why is fascia so important, and why should I care? So this is actually the Manchester Metrolink. It's probably a little bit small for some of you to see. You can actually see, if you really zoom in there, to spinning fields right in the middle of the circle. The circle is the city centre. So think of it as like this. Each one of these is going to represent a myofascial train in the body, which we're going to go through one by one. Each one of them is a train in the body. If there is a blockage, or let's just say something happens and a tram breaks down at any one of these stops. Now, the further away the distal one, so let's go for, I think that we've got the one that's visible there, but I think if you look right to the left on the brown line, you can just about make out that it's warranted. So if there's a blockage there and that tram gets stuck and it can't move because for whatever reason it's been a breakdown, is that then that's going to mess up the entire line going forward. So it's going to create a delay. It's going to create, it's going to create a blockage. It's going to throw the whole system off whack for that one unique line. Now, if you look at somewhere else, if you look further on, and a big one or a key one, we can see, if you look right in the centre and just to the left, we have Trafford Bar. If you look right in the centre, we have Manchester Piccadilly, St. Peter's Square, we have Exchange Square and Market Street. Is that here you can see that certain lines all intersect, where you can then go from one line to another. So that there is a hub spot where all of them come and meet in the same spot. And if there was a breakdown here, and there was a delay, and there was, for some reason, people couldn't get on the tram, this would cause chaos, not just on one line, but all the lines in the intersecting that connect to it. So there's going to be a lot of disruption to the overall working of the Metrolink. And myofascial lines are just the same. So when we have a blockage, it can cause us a problem in the line. But when there's a blockage in one of these universal points, which will be covered today, then we've got an issue because overall movement is going to be effective, and overall, like the delays, the time efficiency of the tram system. So when I say it's as simple as that, that's the concept that we're going to go into. And I'm going to go and explain where these points of the body are and why it's important. So just to summarize, a tram line is a myofascial line. Each of the stops is a muscle in the body. So if we go back to this, and we can see that there's each one as a stop, and each of the line we have a muscle. Now, a restriction or weakness or dysfunction in the muscle. So say a muscle is very, very weak. Say it's very, very tight. Weak, tight, dysfunction, it all means the same thing. But if that muscle is not strong enough to elongate, so lengthen, and do its role from a functional point of view, that means we're going to disrupt the whole line. And if that muscle can't contract, it's going to have, and it's in a position where, let's say it's in one of the hub spots, so the spots which are like Trafford Bar and Cornbrook and St. Peter's Square, say that's a muscle that's there, and that muscle, again, is really tight, really weak, is that's going to affect not just one chain, but the whole chain. And as a result, we're going to see a weakness in the overall body, performance, movement pattern, and so forth. And the great thing about this, and the thing to understand, is that it makes you realize that theoretically, there is absolutely no part of the body which isn't important. Everything is critical. And for any of you who's had a treatment with me, and you've had an issue somewhere far in the body, and I've gone to somewhere nowhere near it and worked on it, that's just because it's about understanding how things interplay and where somebody's biggest weakness is. So I might notice something that's going on in your body and say, right, okay, this is clearly where you're experiencing the pain. However, there's an area which really isn't working, let's work on that, and then suddenly everything improves. And the way you can think about, well, what happened there, was that witchcraft or voodoo? It really wasn't. But say there was a blockage, let's say here again, St. Peter's Square was where the issue was, but really I found that the major issue was somewhere distal and a tram stop you'd never even considered. That's where that's where I'm focused. Improving one area improves the entire system, and that's very, very important for anybody who's got injuries, because when clients come to you, they'll always say, and they say it to me to this day when I get patients coming in, twisted my ankle when I was 7, but that's not a problem anymore. It's like, yes, it's a huge problem, because there's probably some adaptation, some myofascial adaptation in the ankle that you've never addressed, and that's trickled its way up the body. So what I would say, and a big takeaway from this, is that if a client has a problem somewhere, that's going to affect the way they move, walk, run, or train in the gym. Pretty much, definitely, for 100% chance that that's been an adaptation. So here's a really fancy word, which if you want to seem really clever and put this on your Instagram, then feel free to take a picture of this. It's the longest word we're going to speak today, which is called mechanotransduction. We're not saying it's a buzzword, but I was taught about this in we covered this so much in the osteopathy degree, because I had a mentor who was absolutely obsessed with gaits, and she spoke about this over and over and over again. And the reason why it's so important to understand is because it's what fascia's role is meant to do. Mechano is just basically mechanical energy. Transduction is its ability to absorb it and apply it, to absorb it and then produce force. But the fascial trains can be trained. And this is how people develop sports performance. It's how you see small athletes create incredible force. So it's what's going on with the lighter weights categories in weightlifting. It's what's going on with people who can create an insane amount of force from a body to weight ratio. And this is because as we train a movement pattern, we're not just training the muscles, we're training the fascia. And fascia, because it doesn't have a muscular quality, it has a mechanical kind of elastic quality, is that as that fascia becomes more efficient at a pattern, you can apply more force. And again, for anybody who's done my stuff for a long period of time, you'll remember the classic example of, if you gave Eddie Hall, world's strongest man, or was the world's strongest man, you gave him a tennis racket and said to hit it as hard as he can, he could probably hit that ball pretty hard. If you get him to serve next to Roger Federer, and they both served it, it's a no-brainer that Federer would hit that ball harder. But you say, well, who's the stronger individual? It's like, well, it's clearly Eddie Hall. But the thing is that when somebody has done a movement pattern over and over again, the myofascial trains become more efficient at creating kinetic energy through the muscular system and transferring it into the fascial pattern. And that's a big concept that we have to think about when it comes to rehabilitation, and also when it comes to why can't this client feel this muscle and so forth. So think of it as mechanotransduction, is that it's the ability of the entire fascial train to elongate and shorten. And it's based on how often is exposed to a stimulus. So the greater the frequency of the stimulus, the greater the load of the stimulus and the intensity of the stimulus, the better that we move. And a thing as well is that, just to kind of like work on the side of caution, is that if someone says, and this is the thing about debunking myths in this one, if someone says we need to train fascia more, is that that's a bit dumb as well, because there's not really anything we do when we don't train fascia. Like, I'm sat at a desk right now, I am theoretically training the fascia in my neck just by keeping my head up. We're always training fascia in the gym, but it's just the quality of the movements, and the movement pattern itself needs to vary. So if you ever hear someone say, it's very important to train fascia, it is, but that needs a bit more context. It's very important to train fascial chains and fascial movements. But in terms of, are we training it all the time? It's like, well, yeah, we are. We can't move without training fascia to some degree. So the thing that, again, that I've spoken about before, and this is more for the people, is for the people who are in the academy who knows this, is I've spoke a lot about integration training. And when we do program design, there needs to be an element of integration training. We have the myofascial warm-up, which we've spoken about, or a priming drill. And then the second thing is that integration. And the integration is basically teaching something along the myofascial train to connect to the points above it. And by doing this, we stimulate the muscles along that channel. And by doing that, we have a greater ability to then work on the muscle itself. We'll go into this in the next slide, but a really, really simple one is something like the quad. In bodybuilding, how do we warm up our quads? Well, we go on a leg extension. In theory, like, and I'm not having a go at that concept, is like, yeah, okay, we're targeting the quads, but the reason why people have knee pain is probably because the quads have too much power in conjunction with the adjoining structures. Those adjoining structures being hip flexors, the abdominals, and the tibialis anterior. If we worked on something that got the tibialis anterior to work in along with the quad at the same time, so that therefore like a split squat, but something that stimulates the tibialis anterior as well, such as a tib raise, that integration training, so let's just say a tib raise and a split squat put together, that works on that whole anterior line, or the frontal line. And that integration is what improves the whole functioning of the system, and that's going to lead to healthier and better knees. So the problem we have with bodybuilding is that if we work on X, so if we work on the quads, but the quads aren't the problem, we don't see a change in the function of the adjoining muscle. So we don't see a change in what's going on. Like someone says, right, I've got knee pain, I'm doing these leg extensions to warm up, and my knees aren't getting any better. It's like, it's probably because there's a mismatch of force along the myofascial chains that connect to everything along there. So let's work on a few of those. Easiest and simple one in that demonstration is going to be your abdominals and your tibialis anterior. And that's why it's so common when people training in the gym, is that people come to me, I have a problem with X. Everybody's always looked at X, everybody's always treated X. It feels better for a little bit, and then the problem comes back again. So that's because there's a mismatch of forces along the myofascial trains of everything that connects to that, which is why for 90% of people with shoulder issues are more than likely going to be working on the forearms at some point. You know, again, when you'll see this from a visual representation, you'll understand that more. 90% of people who have knee and hip issues, you have to go to the foot. And again, once you see the visuals, you'll understand that again. It's not voodoo. It's just by following the trains. It makes so much more sense when you get a better understanding of it. So these are the myofascial lines. What I will say is that by all means, if you're really into this and want to understand it more, purchase the book, Anatomy Trains by Tom Myers. It's fantastic. It's heavy, you know, there's a lot of anatomy into it. It's such a good investment, but ultimately it's just a good picture book. If you look at the pictures, you can pretty much figure it out, as in terms of like, okay, that's why we do that. But if you want to understand it, I'd 100% recommend that, because it'll give you a better idea of what you're doing and what it looks like. But that's Tom Myers, Myers. Okay, so I've split them up today into 4 sections. This is not the way it's split up into the book. It's just from the visual representations, but plus what I would like to speak about from a relevance point of view in terms of how it transfers to the gym floor and so forth. So in other words, what's relevant for you guys. And I've just put them into 4 sections, which we're going to speak about. So first one, anterior and posterior lines. So looking at the left one at the beginning, at the side there, the left is the deep back line. And this one it starts in the feet, so all the way underneath the big toe. It goes into essentially the Achilles tendon. It becomes the calves. It becomes the hamstrings. It becomes the sacrotuberous ligament. It then becomes the spinal erectus, goes right up our body into the back of the head, otherwise known as the occiput, which is just, let's just call it the back of the head for today. Now, the thing about the deep back line is that it has to constantly work to resist gravity. And in the Anatomy Trains book, it's described as the mast of the ship. So you have a ship which will have obviously a sail, and that sail is attached to a mast which has to be incredibly strong to resist gravity. That is what it is doing. This type of fascia is thick, it's powerful, it's strong, and because it adapts over time from as soon as we can crawl to basically contract to resist gravity. With the anterior line, which is the one on the right of the picture, this one starts with something called your mastoid process. And your mastoid process is just basically you go underneath your ear and there's just a fleshy bit just as a start there. That mastoid process becomes your sternocleidomastoid, which is a neck muscle, which runs into your clavicle or the medial part of your clavicle, then goes into your sternum, It then becomes your abdominal fascia, which goes all the way down into the pelvis or the pubis. It then goes into the ASIS, which is part of the hip, drops down into the quads, into the knee, into the tibialis anterior, and then goes into the top of the toes. If you are interested, and I know Modestus, this is just for you. On the left, we have our bladder channel. So it's our bladder line as a meridian on the left. On the right, we have our stomach channel, which is the anterior one. So now you know that there's a connection there. We got to think, well, what are they for, and how does this affect me? Why should I care? Well, negative postural adaptations is when we have a mismatch of how each one is trained. The anterior naturally needs a lot of eccentric strength because we're falling forward towards the ground. So if you look at the one to the right, the anterior fascia, we're contracting, we're falling forward to the ground, and that one is not going to be able to eccentrically lengthen due to gravity. The only way it can do is if we have a very big concentric movement of the extensors. Well, think about that in terms of, because gravity is pulling us forward and all the muscles along the deep back line have to contract to prevent us from doing this, the anterior fascia doesn't get that great deal of a stimulus unless we're on our back. And that's why, again, for any of you wondering why has Chris got me rolling on the floor and doing all this dumb shit, is because how we going to get some form of stimulus to the anterior muscles and anterior chain. Now, when somebody has lower back pain, and any of your clients have lower back pain, people will always go, you need to strengthen your lower back. And that, in my humble opinion, is not correct, because if we go by that principle of let's strengthen the lower back, is that when we strengthen the posterior chain fascia, we're contracting and we're creating extension forces on the spine. Extension forces on the spine, especially the lumbar spine, is going to push the lumbar vertebrae forward, which is going to irritate the disc, and it's where a lot of what's called spondylolisthesis happens, or basically slip discs. Let's just call it that. A lot of lower back issues come from that. We want the posterior chain, or the posterior fascia, to be able to lengthen and be able to flex and not be so much extended, but we need the anterior fascia to be able to eccentrically load and lengthen. That's what's going to prevent us from having anterior pelvic tilt. Is what's going to prevent us from having that shearing forces on the lower back. And that is why I don't think I'll ever give anybody a leg extension again. Sorry for any bodybuilders. I'm not having a go at you guys, but bodybuilders is not having a go at you guys. But leg extensions increase the strength of the quads from a concentric point of view. And again, it's why when people do shortened range, so setting 2 on a prime, shortened range leg extensions, and they say, this is what's going to give me a teardrop, this is what's going to develop my VMO. Sorry, guys, that's going to mess your knees up, that's going to mess your lower back up. So what we're looking at from this one, just to touch on it again, is that this is my point, is like, it's educating through my experience of working with people who've had injuries. Now let's look at one of the most typical exercises you'll see in any bodybuilding, strength or strongman exercise, and that's an RDL. Now, an RDL is not a bad movement, but when we train an RDL, that is a pure back fascia, so the deep back line exercise. We are just making that fascia stronger, more robust, which, to be honest, isn't a bad thing. I'm not having a go at it. But if you are training it with an imbalance towards the anterior fascia, so you're not doing lengthened work in the abdominals, you're not doing lengthened work in the quads, you're never training your tibialis anterior, you're never training your neck, you're going to run into issues eventually. You're going to run into lower back pain, SI joint pain, hamstring irritation, because you're creating this mismatch where you're sending your body into so much extension. Eventually, it's going to cause problems somewhere. And we haven't even looked at rotational elements on the body yet. So I personally, and again, I'd never say I would never, ever do it ever again in my whole career. But when you see people who are going heavy on the leg extensions, especially in shortened range, people who are doing heavy RDLs and talking about that, I don't care how strong they get, I don't care what they're saying, is that I know for a fact somewhere down the line they're going to run into an issue, especially if they're doing it with load. The easiest tweaks Easiest tweaks to do that is to do a Jefferson curl, so a rounded back straight leg deficit deadlift. That will be amazing. So basically, what looks like terrible technique, which is actually even better for the spine. So if the question was, how do I look after these areas as a bodybuilder, it would be rounded back deficit deadlifts where you really round the spine. I would do those instead of RDLs. I would always do lengthened quad exercises, so setting 3 on the prime exercises if you're going to do leg extensions, and I would be stretching, and I would use the word stretching, or working on hip extensions, so stretching like that quad like nobody's business. Honestly, for sports performance, lower back pain, all the good stuff that we want out of human performance, you can never get that rec fem long enough. And the rec fem is just that quad that sits on top, ASIS that goes into the knee. That needs length tension. The stronger and longer that muscle is, the better you'll perform, especially proximally, so in the fibers towards the top. Right, so key areas, like I said, these are the ones of really key importance. These are your Piccadilly stations, your the ones that I was saying, like where there's loads of intersections where all of them meet at the same time. So posteriorly, we have the triceps surae, which is basically another name. It's not for the back of your arms, it's actually your calves. So it's basically your Achilles tendon. You have your popliteus, which is the back of the knee. Sacrotuberous ligament, which is essentially probably like proximal to your piriformis. It's kind of like the intersection between the sciatic nerve and piriformis. And you have occiput, which is the back of your head. Anteriorly, so the front one, we have the front of the ankle, so the ankle retinaculum, your ASIS, your pubis, sternum, mastoid process. For those of you going, fantastic, what does it mean? It just means work these areas. So train your calves for your feet to be able to rotate. Train your knee to be able to rotate. Knee rotation is so overlooked and so important. Sacrotuberous ligament is that's where we want stuff that's going to be able to train the deep hip rotators. Occiput just means neck. Not saying that bodybuilders or strongmen or everything need to go in and have a neck day, but just a small amount of stimulus to your neck just gets that occiput being able to move, gets the shoulders moving better. Again, some of you will be wondering, oh right, yeah, Chris has given me neck exercises before. That's the logic for it, is that the occiput is so important to human movement because of the amount of changes. It pops up again in the arm lines as well, so it doesn't just affect our anterior fascia, it affects our arm lines as well, which is why I'm an advocate of training the neck. You don't need an iron neck like I've got, as in like the equipment. Just get a band or get a exercise ball and just make sure you train it and do some stimulus. Okay, so arm lines, connection between the hands, forearm, shoulder, and upper arms. Again, I'm sorry about the images in this one. It's not the clearest. If I made it even bigger, then it probably would be not still as blurry. But the general gist of it is that like your flexors. So if everybody is listening to this now, if you just basically put your palm of your hand up towards the ceiling, and then you look at your forearm, if your palm's facing up towards the top of the ceiling, they are your forearm flexors. If you then put your palm the other way, so your palm's facing towards the ground, and look at your forearm, they are your extensors. Your flexors connect from your basically your wrist, the inside of your wrist, or the palmar side of your wrist, and it goes in through the flexors, through the inside of the elbow, up the bicep, and into the chest that you can see there. So if you look at the guy in the top left, it goes through the chest on that one. Then the deep line, so the deep arm line, goes a little bit more into the bicep, and it goes into the pec minor. So in other words, the palmar side, so basically when we're supinated, palm up towards the ceiling, that goes into our forearms, into our bicep, into our chest. From a extensor's point of view, if your palm is facing down and you look at your hand, is that then goes on the outside up towards the elbow, up into the tricep, up into the infraspinatus, and also into the traps and skull. As you can see from the bottom one, so the extensors, so the deep arm line, the back line, that also goes into the occiput. So that's why I said is that the thing that commonly gets overlooked is the way we can stabilize our skull and stabilize the neck. It gets a bad rep because of that Joel, whoever he's called, guy from. He's got loads of followers and he does dumb stuff with his neck and doing, neck attachments and then doing trap bar deadlifts, and that's why people would almost be scared to train the neck. Like I said, you don't need a neck day. You don't need to be going into a bodybuilding gym and doing all these things. It just means at some point in your week, just doing something where even if it's just moving your neck in different directions, just doing some flexion, extension, rotations, or circles, doing it at home when you've been at a desk and putting it into a stability ball, just getting it to move is going to do that little bit to improve. If you need specificity, obviously that's where I come in, but let's not worry about it for now. The main thing is, again, it's that occiput. The better the occiput moves, the better these lines will move themselves. Now, I always say, like, people go on about the rotator cuff and they go about the infraspinatus, subscapularis, and so forth, and like that. Your true rotator cuff is in your forearms. It always is, and it always will be. In other words, if you can't supinate and pronate, and you can't do that with strength and the range from side to side, you're going to have shoulder issues. That's why, again, for people who said, I'm a huge fan of Indian clubs, so the maces that you see. I use them in my own training pretty much every session. I rehab people with it, and it's just actually training supination and pronation is really useful. If you're a skilled bodybuilder, you can do this through doing rows just by hand placement. So basically, how you pressure through your index finger and how you pressure through your little finger. In a really simplistic way, when we squeeze through our ring and our little finger, so really squeeze hard through those areas, we're going to engage the posterior arm lines more. So we're going to engage our deep extensors. We're going to extend our triceps and infraspinatus. And by contracting and really squeezing those muscles, we'll train the rotator cuff, or the infraspinatus, so much more. But if you ever have a client who goes to anybody for a shoulder issue and they say it's the rotator cuff, always look at their supination, forearms, and movement, because that's a big thing. With bodybuilders, this is again the problem, and sorry, bodybuilders, for having to go to you so much. I'm just being plain devil's advocate here. Is that when you get very, very strong using grips, very, very strong using grips in a set position, so a set grip, so overhand or neutral grip or whichever, when you do any of that, what you're doing is that you can create irritation, or you can create tightness, or you can reduce your ability to supinate and pronate. And if you already have a pre-existing shoulder issue, or you already have a pre-existing issue somewhere else, that's where the problems arises. So as soon as you're losing your ability to pronate and supinate, you're gonna be increasing the likelihood of developing shoulder irritation and issues. So I think they're pretty much covered with that, is that the arm lines can be elongated and changed. So again, what's the biggest thing that you want in physique development? Is you want symmetry. You really want symmetry, which is a big thing. But what happens is that when there's a shortening of anything along these channels, so a shortening of the extensors, specifically more in the hands and the forearms, this is then going to prevent the lengthening of everything across that chain, i.e. the chest. Now, the amount of people who come into me, I can't feel my chest. And then you look at them and you say, you spend 8 hours a day on your phone texting. It's like, that's going to shorten the thumb, shorten the muscles in the thumb, shorten your extensors, shorten everything there. And it's like, well, no wonder you can't get into your chest, because you're so contracted in those flexors. You can't elongate that fascial line. You can't access the chest itself. So this is where, like, again, when we spoke about myofascial flossing, you can put your palm against the wall and turn away. If that is ridiculously tight, it shows you're weak in your forearms, and it shows you're obviously not elongating that chain or doing anything in that line. So this is where, looking at the big picture, have you got clients who have broken the wrist? Have you got clients who have ever fractured anything in the hands? Have you got clients who are boxers or done any fighting sports where they've done a lot of punches, which has then got them to be even more contracted in the fascia? And again, this is why they can't connect, or they have an uneven connection to one side, or keep running into an issue with one side of the body. Key areas for the arm lines is the hypothena, or the thenar and hypothena, which let's just call it your thumb, your bicep aponeurosis, your ulnar aponeurosis, let's just call that the elbow. Sorry for being a bit fancy there. Coracoid process, which is the front of your shoulder, and your clavicle. These are just key attachment sites. It's why I'm a big fan of just chest flies. They got demonized by all the biomechanics wizards out there saying, chest flies are terrible, they don't train the strength curve, blah, blah, blah. They just stretch chest, don't care what you say. I know it's not for hypertrophy. But a dumbbell chest fly as a warm-up is just opening up that fascia, especially if you rotate your hands. So if you pronate and supinate in different directions, you're just going to open up your forearms. It'll feel really nice. I know it's not for hypertrophy. It just means you're opening up, keeping your shoulders a little bit healthy. For the back lines, you've got your olecranon process. Again, that's just your elbow, let's just say. Posterior deltoid and your CDJ. CDJ and occiput. CDJ is just basically where this your neck meets your upper back, let's just say. Very, very important spot as well. For those of you who are in the academy, if you haven't noticed already, coracoid process, posterior delt, what are those? Those are points 1 and 3 in the model. So in the, 1 and 2 in the model. Point 1, coracoid process. Point 2, posterior deltoid. In that foundations model, it's just the myofascial points. If we elongate one point, elongate the other point, and get those to be able to move and flow and stretch, shall we say, and move and function better, we see an overall improvement in movement. Okay, deep lines. These are kind of like my favorite, which sounds a bit silly really, but these are like the osteopathic ones. They're really cool, kind of what really deeply connects everything to everything. The deep lines is what I would call your respiration layer. The reason why is because it connects to things like your deep toe flexors, so the muscles that help stabilize the foot, your pelvic floor, your hip flexors, your psoas, your diaphragm, your neck, and it all interchanges. It also connects around the visceral organs as well. So it's these ones are going to connect to things like your intestines, your liver, your stomach, all that type of stuff. And I think that this one from the osteopathic point of view is that when you work and you really open up these channels, and I think there will be some of you who have done visceral work on where we've worked on the abdomen, we've worked on deeper layers of fascia. This is where you see like a general release. When people are very, very stressed and they've had a lot of systemic stress in their body, these can become very, very contracted, and it's what you want to work on as well. From an applicable point of view, so you as a personal trainer, it creates axial stability. So it's what stabilizes the spine, rib cage, and skull. So if somebody's breathing is jacked up and somebody's feet are really weak, this is the line which is going to be very, very contracted. If this line is very, very contracted, you can probably see that they're not going to be able to move very well at all. So if you were thinking, how do I stimulate this? Well, this is showing how important pelvic floor and breathing actually is that if you look at that connects so much to everything. If you have weak feet, if you have a weak pelvic floor, if you have a weak diaphragm and you can't breathe, and that line is extremely, extremely tight, of course you're going to get injured because your body doesn't move. You know, if you try and do something like run, you know, you might be able to run for a little bit, but you're going to have a problem with the knee. You're going to have a problem with your lower back or your neck or something like that. Is because that is a representation of how deep this fascial network can run throughout the body. It also shows a huge, huge emphasis on the importance of the adductors and why having nice, long and strong adductors is so important. Again, sorry, bodybuilders, and again, not having to go too much, but this is why you've got to be careful. I will use like shortened range adductor movement. So I will use like right in certain circumstances, but you are again much, much better off utilizing a lengthened range when stimulating adductors. Adductors really need to be long and strong. And the reason for that is that that's going to help us flex and extend the hip. It's also going to help us stabilize the pelvis. If you're going to shorten the adductors, such as something like a Copenhagen plank, you want the pelvis to move around it. So I would call that a dynamic Copenhagen plank, where you're stabilizing using one adductor and then bringing the knee up and down on the other side. That's really important. That's brilliant because you're stabilizing one adductor whilst mobilizing the other, and that's where a lot of magic can happen. So what I love about the deep line is that it just really emphasizes how the adductors are so important because they're an incredible myofascial structure. It also illustrates how foot function can affect the pelvis and neck. If you look there, you can see what you call your deep toe flexors. Your deep toe, you've got your hallucis longus, you've got your deep toe flexors as well. Where your tibialis posterior and your hallucis longus, which is on the right hand side. Those muscles are incredibly important for creating an arch in the foot. When they're weak, you can see how that affects the whole stability of the pelvis. So when people say to me, are the feet important? Yeah, well, this demonstrates it, because if we have a weakness in the foot, we're going to have a weakness in that chain that goes all the way up through the deep flex of the body, into the hamstrings, into the adductors, into the pelvis, and so forth. But again, everything works as well. So we can't have a strong foot because if we have a weak pelvis. So this is why when I spoke to you guys a few weeks ago about program design, foot stabilization and spinal stabilization need to be in there somewhere. And that's what, I will be brutally honest, like when people come to me and say, I don't want to do the rehab, or I find the rehab boring, or, I was doing it for a little bit, but then I fell out of it. I'm like, right, that's fine. Don't worry about it. But if and when you do fall into an issue later down the line, I tried to tell you the importance of it. It's very, very easy to fall out of this. I will do it myself at times, like, I don't really need to work on these things. Training's going well. I'm getting stronger. I'm getting better. But ultimately, if you aren't prioritizing this and keeping it, and then this is the key thing, keeping it synchronized with the level of strength you require with the rest of the body, you've got an issue. What do I mean by that? Well, this is where people go, when there's no kind of thought process behind center of pressure through the foot, people get incredibly strong at leg presses, but they're essentially just pushing through their heel. And as a byproduct, through cutting off the foot and not stabilizing through the foot, and they get this crazy strong leg press, is that, yeah, they've got huge quads and they've got huge hamstrings and glutes, but they have very, very weak and tight feet and shin muscles. Of course, they're going to get knee issues. Of course, they're going to get lower back issues. So again, you heard it here. You heard it here first, guys. If you want to be strong, if you want to be healthy, if you want to move well, if you want to get big, which is all amazing stuff, please remember this stuff is important and it's not going to change. So key areas: toe flexors, foot arch, adductors, psoas, diaphragm, sternum, neck. Like if you want to be like absolute like badass trainer, online, in person, don't care, teach clients about this stuff. Get them to get shiatsu mats, which is the spiky mats. Get them to roll the feet with a ball, get them to do stuff which stretches the adductors, however you want to stretch the adductors. Get them stuff which strengthens the psoas through training. Train their psoas, train their hip flexors. People, before anybody asks about that like meat hook thing that you lie on to release the psoas, not a fan of those, just in case, just if someone was going to ask. Diaphragm, very simple, get them breathing. Neck, obviously, get them doing some form of neck stimulus. Spiral and lateral lines. So again, really cool stuff for me. And this one is a big one for which will have a massive penny drop moment when it comes to things like squats. The one to the left, so that the spiral line, that is your squat line. That is what enables us to squat and walk. It's such a cool concept when we think about it. So spiral lines is that thing which is like, right, how does one hip affect the opposing shoulder? Why is it that, you guys come into me and you say that, my knee hurts on one side and I might work on your right wrist when it's the left knee? This is why. And it's because there's an intersection of movement, and basically we need one side of this spiral line to contract and one to lengthen at the same time the opposing side does the other thing. So sorry, I'll say that again. So when your right shoulder is moving towards your left hip, so the anterior part of that is shortening and the posterior part is lengthening, obviously we have the opposite occurring on the other side. And when we talked about this foundation model in the course in the APX Academy, we talk about that foundation model, about number one moving towards number three. So point one going to point number three. This myofascial spiral line shows that. It shows how it connects. And again, it's just from my point of view, like it's such an important thing to train. And it's why a lot of the stuff I do involves stabilizing the foot whilst twisting, rotating, bending, and so forth. The one to the right, and I do apologize because it's not the greatest of images, is the lateral line. And the lateral line there is one that goes from the outside of the body and runs ipsilaterally. So it doesn't cross the body, but it goes all the way through the side, through the hip, through the through the like lateral hip fascia, through the rib cage and into the neck. And that's one's very important for side bending and being strong in single leg stance. So when we're walking, that one needs to be incredibly strong. A quote from this, if you want to write it down, if you want to tell the world, is that you can never be too strong in your lateral hip muscles. So your TFL, your glute min, your glute med, the posterior lateral aspects of your glute max, they can never be too strong in terms of being able to facilitate that single leg stance and internal and external rotation. The stronger they get, the stronger the individual gets. And you'll see for me absolutely hammering those 45-degree side bend movements on the 45-degree back extension. That's why. The stronger they get, the stronger the human gets. So in terms of the one, going back to this spiral line again, so I'm just going to take your attention back to this guy on the right, on the left, sorry, is that we've got tibialis anterior and we've got the fibularis. So the fibularis muscle is the one, if you were looking at this guy's knee on the left, that one there is that, again, tibialis and fibularis muscle. Those work together to create external rotation of the foot. And if you looked at the last Instagram post I did, which is about squat mechanics, that we do need that for a squat. We do need the tibia to externally rotate to squat well. We also need the TFL to contract, to abduct. So basically to point the knees out. And that's actually quite interesting because the TFL is an internal rotator. Join gait, it's an abductor join a squat. Sorry if that went over your head, but I'm just going to say that again. It's an abductor join a squat and an internal rotator join walking. It has two different roles depending on what we do, and that's functional anatomy. So what this allows us to do is that when we create torsion in the tibialis anterior and the fibularis muscle, we create external rotation, we have a strong TFL. This basically creates this insanely strong hammock and space for our pelvis to drop down and our torso to be bolt upright when we do a squat. And that's how we create it. And we create that squat strength through that spiral line to keep us central in that position. Now, obviously, we have these other lines that come into play, such as the posterior fascia, the deep fascial line. That's going to give us a lot of integrity there. But remember, if we're doing something and we make one of the muscles on this line very, very tight or restricted, we're then going to create a restriction or rotation in the way that fascia moves. Let's just say you are somebody who has a kicking background. Let's just say you have someone who's done football, or you've done any type of kicking sport or martial arts. Let's just say you're a skateboarder, because I've had bodybuilders who've got skateboarding backgrounds. The asymmetries that you create in this spiral line is insane in terms of strength, length, and force production. You then go into doing stuff like bilateral movements, such as squats and deadlifts. What do you think is going to happen? Of course, there's going to be rotation. Of course, there's going to be some form of movement to the side. So this is the thing that I'm saying to people is that, in all this type of thing is that you don't want to just do this fluffy mobility work. You need to become insanely strong and be able to stabilize through the feet, stabilize through the hips, and create rotation, or stabilize through the shoulders whilst moving something in the hips and the feet at the same time. And again, that's what you'll learn through all the APX stuff. It's the point of it. So like I said before, is just a little summary. The lateral line, so the one on the right going to there, this one is very important for single leg support. And it demonstrates the link between the lateral aspects of the body. Very, very important with females. So when you have females with hips which kink from side to side and sway from side to side, that can be a huge factor, especially with the neck. A lot of women with hip instabilities will use the neck to stabilize themselves, which is why they get headaches because they're not strong enough through the feet and through the hips. That line shows that. But as I said before, is that lateral line is very, very important for your single leg support, which can never be too strong. The reason being is that the forces you apply to the ground during sprinting, or what we should do, are exponentially greater than anything you could do in the gym. Exponentially greater. When I say exponentially greater, like 10x, like 10 times greater force than you're producing. I know, like if you looked at the way Eddie Hall lifted during the deadlift and so forth, and how much force he had to produce to break that deadlift, if we compare that to what Usain Bolt's putting into a track when he's running at 28 miles per hour, it does not compare. That's why the lateral aspects of the body can never be too strong. So key points here: your tibialis anterior. I'll give knee over toes guy that one. I'll give him that one. Is that, tibialis anterior is really important for functioning one. Your fibularis muscles, so the lateral muscles of those, once they're rock solid, we've got a problem with that whole lateral line, the whole spiral line. Fibularis muscles, so your fibularis longus is actually one muscle, which if I could only work on one area of the body on someone, it probably would be that muscle. That's how important that one is. And your fibularis is just the outside of your shins. Bicep femoris, which is your lateral hamstring. Your TFL, oh my God, that is an insanely important muscle. But that intersection, so your ASIS, stretch it, work it, move it however you want. But TFL, I don't mean just doing like, right, we're going to train the TFL directly. I mean that area needs to be able to move and lengthen and be able to contract and snap back as well. So TFL is such an important area. And for anyone who's unsure, it's just that like kind of thick muscle which is just over the trochanter there. And serratus anterior and rhomboids, which again, those are the same muscle. Like if I was to kind of summarize those, is that your serratus anterior muscle, which is a shoulder stabilizer, and your rhomboid is the same muscle. They should be able to contract together to create protraction of that shoulder, which is really essential for flexion and external rotation of the upper arm and basically extension of the upper arm as well. We need the serratus and rhomboids to integrate together. When anybody's got their shoulders by their ears, so say you've got a client who has a problem with the neck, just for anybody listening who has clients who have problems with the neck, check the serratus anterior and rhomboid, and then you can see through that spiral line, if it's the left side that they have the issue on, how it wraps around and goes into that right hip, which if they ever have any previous knee issues, that's an indication of why that's the case. Right, application. So the most important thing about today. So structural balance, what does that mean? Well, it's down to all individuals really, because it requires stimulating various myofascial lines in a way that elongates the chain. So what I mean by this, guys, is that you want to be able to, if you think about all these lines that we've looked at today, all these channels and chains and everything, you've got to look about, okay, if I don't feel confident enough getting people to do these funky, weird stuff in the gym or all the stuff you see on my page, what can I get them to do which is going to stimulate us in some way? Can I get them to stuff to do at home? Can I put some stuff together where I say, right, if you're at your desk, just get up and do this for a little bit. Just do this stretch, do this yoga pose, do this whatever. But if in terms of if this person, if we come away from that reductionist idea that muscles just contract and do one thing, and they have to work along that chain, if we get them to do something which opens up that chain in some way, that's going to help the function of that whole chain and therefore that muscle. And it needs to be in the program somewhere. And the more you can get somebody to do this type of thing, the more you're going to reduce the likelihood of them to do like boring mobility. When I say boring mobility, is that mobility where you are doing something passive, where you're holding a stretch, is different from a myofascial floss. A myofascial floss is looking to open and lengthen a chain, and they are pretty uncomfortable whilst you're trying to create stability somewhere else. And again, anybody who's seen me will understand that we've probably done this in person. We're trying to stabilize through the foot or the hand whilst we move the body around it and maintain and sustain a position whilst we're getting the fascia to move. And it actually creates an insane amount of strength. And I will put up a video soon what I mean. And a simple one, think of this as a simple one. Go into a kneeling position, not now, but at some point in your day, go into a kneeling position. Tuck your hips underneath you, so you're in a, let's just say, a neutral pelvis position, or you're not in too much anterior tilt, and bring your heel to your bum on that side, and you'll feel your hamstring contract. As that hamstring's contracting, you'll feel a stretch in the front of your quad. So we're strengthening it, we're stretching that rec fem, and that'll help improve the length tension. It'll have a small effect on the myofascia, not massively, but it will affect the myofascia. If you do that in conjunction with foam rolling that quad or doing a theragun on that quad, if you contract that hamstring very, very hard, the DOMs and strength you need to bring your foot up towards your bum, just like you would do in a sprinting motion, is actually much greater than you actually think. And this is what I mean by using strength to change myofascial chains rather than just doing passive mobility where we're just moving. We need to be strong in these movements in order for it to stick. And I know that for a fact, because if I've got a 100-kilo bodybuilder who's got an issue, we had to use very heavy movements where they had to stabilize in order to make a change to their body. Otherwise, they would not make a change long term. You have to be strong in these shorten and lengthen movements depending on what you're trying to do. Whenever you shorten one muscle, such as a hamstring, you're going to lengthen the quad, which is why it's so useful. So think of it like this. And again, it's really simple. You've got a client and they're the one on the right. They don't get stimulated. They don't get any form of stimulus in their life where they're opening up their body in terms of a myofascial way. So in other words, they're sat at a desk all day, then they're going to do one of your programs in the gym where they're on machines, they're on stuff, and they're not moving and changing the contractile ability and the health and length tension of this myofascial network that we've got. Then you've got somebody on the right, on the left, who is the epitome of utilizing fascia for its purpose, which is sprinting. Now, my kind of model from a training point of view, if someone works with me, I want to get them to a point where they sprint. Why? Because they will be a better functioning, faster, more injury resilient individual, without a shadow of a doubt. That doesn't mean they're going to sprint next week. It doesn't mean they're going to sprint next month. It doesn't mean they're sprint in 6 months' time based on where they're up to. But you've got to use common sense with this, is that if we know that muscles, and I'll start again, because if anybody wants to put this on their Instagram as a little soundbite, feel free. I'll give you a sec to get your phone out. But if we know muscles contract along a myofascial chain, we need to stimulate that myofascial chain through lengthening it in some format at a stimulus where it then will adapt. So intensity or load. That is how you get muscles to fire in synchronicity, which is going to improve joint function and therefore reduce pain. That's why fascia is important. When we use a reductionist point of view of just getting a muscle to work individually, that can help if you have identified the muscle in the chain, which was the specific weakness. But that stimulation, we then need to integrate it back into the pattern. So say, for example, someone has incredibly weak tibialis anterior. A lot of people do. We're going to stimulate that muscle, but then we need to teach that person how to be on their feet and utilize that tibialis anterior in the movement pattern we want them to do. And that is why, in my opinion, gym floor PT will always trump online, because you can do this and teach people what it feels like, which is why it's so important. So think of it like this. We're working with the people on the right. We want them to become the people on the left. How we do that, it's a long process, but that's the goal. And we need to do it, very intelligently based on who we're working with. So just to summarize, understanding myofascia doesn't mean you have to come away from traditional modes of training. I do apologize to the bodybuilders. I wasn't having a go at yet. I'm just highlighting why we need to look at this in terms of a holistic health. It just means including elements of movement which stimulate the meridians with the appropriate load. So appropriate load for a lot of people is just body weight. As they get stronger, we can add things in. Don't assume that a strong individual will be able to do things, in a strong length and range to begin with. It's probably the opposite. If someone's very strong, they're probably going to be quite weak in length and ranges. Saying that, if we want them to adapt, we do need a required amount of load. So we do need to improve the load on things. You can either do it in the session if you have the skill and knowledge to do that, or you do it in external format, so you get them to do it outside of the gym. Jokes aside, things like dancing, things like sport, things like low level, the reason why people get injured doing sports is because the intensity was too high. That's simple, is that they don't have good, let's say, myofascial contractions. They don't know how to use their body efficiently. They've just gone in too high intensity for their body. The appropriate level intensity dynamic movements, such as any type of sport, is amazing for people. It is what will keep people healthier and improve longevity going way into the older years. And that can be any sport they want that they enjoy. And an enjoyment factor is huge with this. But if you really wanted to create this best kind of version of yourself, a form of leaps, bounds, sprints specific to you and done at the right intensity is the best thing going forward. So what to do is that focus on myofascial holding points, and that just basically means grip and feet. Your grip and feet can never be too strong. Work on dynamic rotation of the foot and the grip, and that is where the magic happens. It's so important. You can work on myofascial flosses prior to training, and that's, again, stuff where you're rotating and twisting, things like neck, forearms, where you get that deep stretch, which, again, we cover a lot of in the academy, which you guys already know. Work on mobilizing and working on any of the key areas in the presentation. So when I say key areas, the key areas are the occiput, the TFL, the neck, the sternum, the toe flexors, the sacrotuberous ligaments, so basically the piriformis. Those areas, when you mobilize and strengthen them, they have a profound effect on the rest of the chains, which is really really important. Functional movement. Now, when I say functional movement, I put it in quotations. Some of you did attend the functional movement webinar. That can be stuff like just a reverse lunge and rotation. It can be stuff with an overhead movement. You can, when I say functional movement, it's just where we're moving in dynamic, twisting, bending motions. You can't really get that wrong. Like, as long as somebody doesn't have an injury, as long as they're fit and healthy, they have no pre-existing factors, as long as you don't load them too heavily, it has a reason for it. Just getting someone to move in a way that they're unaccustomed to, or they're not getting exposed to, is great for them. So similar, just a reverse lunge and a twist. That's the easiest and simple one. Just get people to do that from a body weight point of view. Biggest mistake people can make, or a mistake people make, is when they're adding too much load too quickly. So walking lunges with weights. So many people don't even warrant using dumbbells when doing walking lunges because they can't stabilize to begin with. But get people moving, bending, twisting at some point. And then the final one, it does sound like I'm biased, but the reason I got into sprinting is that because when I designed the Apex Level 1 course, it just, the more you look into sprinting mechanics, the more you realize it's what the body is designed to do. And if you want to be healthy, have longevity, feel better, improve your hormones, and have less need to do mobility and feel stronger within yourself, develop your central nervous system, you would do some form of sprinting. And that is, again, sounds like I'm biased, but that's what I'm up to with
Hi guys, Chris here. Just want to say a massive thanks for watching today's webinar. If you like what you saw and you'd like to learn more about how APX education helped you learn about anatomy, functional movement, how to maximize performance, the link to the APX website can be found in the description. If you head there, you'll be able to see the courses and program design options available if that's something you'd like to learn more about.